Okay, so here's a slightly more complicated problem, and I haven't done this one yet, and it scares me a little bit that it says super bonus, so I don't know. I guess you'll never know if I delete the video and try again, but I'm going to try to go through it the first time. Okay, so I haven't done it. Okay, so a driver of a car is going 90 kilometers per hour, suddenly sees the lights of a barrier 40 meters ahead. It takes the driver 0.75 seconds before he applies the brakes. This is known as reaction time, okay? Once he does begin to brake, he decelerates, ooh, don't like that word, I might change it, at a rate of 10 meters per second squared. Does he hit the barrier? Okay, we'll just worry about that first. Okay, so the first thing you want to do when you approach a problem is again, draw the picture. So here we go. So here's my little car, okay, and a couple different things are happening, right? So this is the initial, okay, and then this is the final kind of for part one, right? Because this is the time where it's 0.05 seconds where he's moving at a constant speed, right? Because he's still going 90 kilometers per hour, okay, before he applies the brakes, okay? And the barrier is 40 meters ahead, but that's the whole distance, right? So that's 40 meters, okay. Once he does begin to brake, now he's going to slow down at a rate of 10 meters per second squared. Okay, so now I see that he's slowing down. I need to be careful. I'm going to set my positive direction this way. Okay, and he's moving in a positive direction, so I need to know that that's going to be a negative, right? I need to know that, all right? Does he hit the barrier? Well, who knows? Okay, all right, good. Okay, so what you can see here, the main point is in this whole scenario, it is not one constant acceleration, right? So you're going to need to look at this in two parts. Okay, you have the first part where the car is moving at a constant speed, and then you have the second part where he's braking, okay? So the first thing to realize is that there's two pieces to this problem, okay? All right, I don't like that color. Okay, so let's look at part one. Okay, this is where he's moving at a constant velocity. All right, so this one's pretty easy, right? I can just do x final equals vt plus x naught, all right? We'll assume that the x naught is 0, right? Because we'll just set that as like our origin because it doesn't really say. All right, and we know how fast he's moving and we know the time, so we can find out basically, right, our delta x. Okay, so now 90 kilometers per hour is kind of a problem. Okay, so you can do something like this, but they really don't do this stuff on the AP test, really. 1 kilometer, meters, blah, 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 right? So I'm just going to do the cheat way, and I'm just going to look it up online because I don't feel like figuring all that out, right? Because on the AP test, they're not really going to do too much with that, okay? So I should have probably pre-looked that up. So I'm just going to do a little Google search, kilometer per hour, 2 meters per second. Because you always want to use meters per second when possible, right? Because it's just kind of like the common thing. Oh, my thing doesn't work. Great. Okay, hold on. I have to try my phone. I'm outside, so. Okay, so let's see. Kilometers per hour to meters per second. I guess if you're on the video, you can always, skip ahead while I figure this out. Meters per second. Okay. I could have just calculated it by now. All right, so 90 kilometers is probably like 30 meters per second or some easy thing. 25, see? I knew it was going to be some clean number. 25 meters per second. Okay. All right, so it's going to be 25 meters per second. 25 meters per second. Okay, so my displacement is going to be 25 meters per second times 0.75 seconds. Notice my seconds cancel. Okay, so I'm going to have 25 times 0.75. Oh, and I'm sure y'all have a good calculator, right? But it makes your life a lot easier. Don't use your phone like I am. 18.75 meters. Okay? All right, so in this first section here, I don't want to use blue. This part up to here is 18.75 meters. Okay, so the rest of it is 21.25 meters. Okay, so now what I need to figure out is, based on the speed that he's going here, 25 meters per second, is that enough distance to stop? Okay, so there's a couple different ways you can solve for it, but I think what I'll do is I'll solve for the distance that he travels or his displacement, and then see if it's more or less than 21.25. I think that should work, okay? So I'm going to start with writing down my displacement is what I'm technically trying to find. My initial velocity now is 25 meters per second, right? Because I've moved into stage 2, Okay, so my final from the first part was 25, but the initial for the next part is also 25, okay? My final velocity is going to be, we don't really know because he didn't hit the barrier. We're trying to see if he'll make it. Okay, and let's see, what else do we know? The acceleration is -10. Okay, and let's see, we might have to use the thing. Does it give us anything else? What else does it say? Does he hit the barrier? 75 seconds to react, blah, 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 blah. Okay, so I don't really know the time either. Okay, so I don't know the time. I don't know the displacement. I don't know really anything else. Oh, actually, I do want to say the final velocity is 0, right? Because I want him to stop before he hits the barrier, right? Because if he was still moving, he'd hit the barrier. So I think actually we do want this to be 0, okay? So you have to kind of read into the problem, like when there's secret things given that aren't specifically given, right? You have to kind of think about the situation. Okay, so I think I can just do that now. I don't care about the time. Let me use this equation, right? Because I can solve for the delta x now. Okay, all right, so this goes away right away. So I'm going to go ahead and isolate for the delta x. Then I get a nice clean, this guy, okay? All right, move down here a little bit. Okay, so now delta x equals -25 meters per second squared over 2 times -10. Okay, now this negative, right, came about because I moved it to the other side. So that doesn't square out, right? That if it was a negative, if the velocity was negative, that would have squared out, but this one does not. Okay, so this is going to be negative, what is that, 625 meters squared per second squared over -20 meters per second squared. Okay, and take a look at the units, right, and see how those units are going to cancel out to be meters. Okay, so -625 over -20 is positive 31.25, cancel, 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 meters. Okay, so in order to stop moving that speed, you're going to need 31.25 meters. Okay, but I only had 25, right, because I had the first one was, 18.75 plus I need another 31.25, and that's going to be, 50 meters. Okay, so he's going to have a sad ending to that. Okay, all right, so it's really about being, think about what's happening in the problem, draw it out, talk through the scenario. When the problems get harder, talk it through with somebody, kind of like see what you know. Write down your givens. Okay, so see here, I've written down all my givens. All right, this one I didn't because it was so easy. I've written down all my givens, figuring out which equation to use, carefully going through, isolating the variable, working on the units, get the answer. Okay?